Hello everyone, welcome to the Structural Geek. This is a small video on stable structures. So, how do we decide whether a structure is stable or not? So, let's say for any given forces, if the structure does not lead to an infinite deformation, we can say that the structure is stable. Or, let's say in other words, if there is a possibility to ground any load that is coming onto the structure without it becoming a mechanism, then it can be a stable structure. So, let's take an example. Let's take that a frame that you have over here, which is a 2D frame, so that has the possibility of having translational in x direction, translation in y direction, and a rotation in the z direction. So for any set of loads that can occur through these three mechanisms, if the structure does not lead to an infinite deformation, we can say the structure is stable. Let's say if we have a load coming in x direction acting at this point, so if let's say there is a possibility to ground that force through the support reactions and the structure does not falling and becoming it a mechanism. We are not saying over here that the structure cannot collapse. Structure can collapse as the support being failed or any member being failed in the stresses that it is being developed. So we do not say that it cannot fail. So the stability does not mean the structure cannot fail. Now let's take some examples to just understand that how this which frames are stable or not. We will be taking few examples there. So here we have some structures, maybe three continuous beams or a normal beam that we have, and we have three frames. We need to judge that which of these structures are stable and which are not. So let's take example of this structure. Since any load that can happen on this plane frame is mostly can be sustained by the vertical force that we have over here, the vertical reaction, the horizontal reaction, and a moment over here. So here we can say that the structure is stable. If we come on to this structure, although this support does not have the fixity, but any load that is coming, let's say in between, that can be the moment generated by that can be counteracted by the vertical reaction being developed at any of these locations. So this can is also a stable structure. But if we come to this particular structure, which is only having a pinned support at one end and another end is free, this cannot be a stable structure. And the reason for that is, let's say a load coming at and acting at this particular point will generate a moment, and the vertical and the horizontal reaction capacity will not be able to take care of that moment, so it will essentially be unstable for any minuscule force that is being acted upon this structure. So this is not a stable structure. Similarly, let's take few examples out of these frames. So here is a completely fixed frame, fixed at the base, fixed at the top as well at the joint. This is a completely stable frame, and it can take any load that is coming in as a 2D frame on this particular structure. Whereas the frame that we have in this at this location, which is pinned at the bottom and also it's pinned at the beam and column junction, this will actually sway away whenever, or even not even sway away, it will be an unstable frame as we try to push it into the horizontal direction. So that's a unstable frame and it cannot take any horizontal load that is coming off. And the reason for that is the any horizontal force that you push onto the structure, there is no possibility to have a horizontal force over here, because if we try to have a horizontal reaction at this location, it will develop a non-zero moment, which is not the possibility. So that's why for the frame cannot sustain any horizontal force and lead to infinite deformation. The structure is unstable. Now the third example, which is similar like a second frame only, the only thing that has been changed is like a tension member or a brace has or a axial compression member has been reduced over here. This can actually take the forces, and this will be a stable frame because by virtue of this, by virtue of axial capacity of this particular member, the structure is stable for any horizontal load, and for vertical loads as well. This member will be helping. I hope you guys had a nice learning. Please subscribe to the channel and like the video.